So I think this is beautiful, and it's the most elegant and sophisticated system out there today. See for yourself in this new flight video.
Oh, dang it.
So Amazon came up with this really cool thing called the Prime Air drone, and before I get into the much smaller version of it that I made, I wanted to first talk about the really interesting design features that the engineers at Amazon came up with in order to make their vehicle much more efficient. And just as a disclaimer, I do not work at Amazon, nor do I know anybody who works there, so all of what I'm about to say is simply speculation into their design thinking and decision making on this vehicle. Okay, let's get started. Now, Amazon has gone through quite a few configurations of their Prime Air drone, but their latest is definitely their best yet. To start, it's a tail-sitter configuration. What does that mean? Well, it means exactly what it sounds like. The vehicle sits with its tail pointing down and the nose pointing up. This configuration is actually quite similar to what I've worked on in the past with something called the quad-rotor biplane tail-sitter. Our versions of the quad-rotor biplane have been very simple though, because it's essentially just a quadcopter with two wings strapped to the bottom for improved forward flight efficiency. Now, the Amazon Prime drone isn't so different from the quad biplane, but there are a lot of really interesting things that engineers chose to do. These things namely include the wing configuration and the rotor and motor configuration. First of all, there's a ton of angles going on here. The wing is mounted at this weird angle, the fuselage is mounted in the same way, but the motors are perpendicular and it takes off like this. It's weird, so let me break it down for you. The wings are mounted with about a negative 30-degree incidence angle in order to make the transition to forward flight easier. By putting the wings at this angle, the wings can avoid stall conditions much easier, because suddenly the wings don't need to transition to 90 degrees. Instead, they only need to transition 60 degrees. The fuselage is also mounted at this angle, in order to limit drag in forward flight. Another nice thing about this is the vehicle can avoid gimbal lock because it doesn't need to transition 90 degrees. I assume this makes the flight control software much easier to work with. The wings are also mounted on the outside of the vehicle's rotors, which protects people near and around the vehicle from accidentally walking into the rotors while they are spinning. And with the wings mounted on the side like this, they can improve the lateral stability of the vehicle in forward flight, because they essentially act as vertical stabilizers. Not only this, but with the loud rotors surrounded by this big wing, I assume there's quite a bit of reduced noise levels coming from the rotors themselves, which is important considering they plan to have these things flying around all the time and they don't want to annoy people.
I am proposing to shoot it down.
Okay, next thing, the rotors. There are a total of 6 rotors and motors on the vehicle. The outer 4, I assume, are primarily meant for hover conditions. How do I know this? Well, they are 3-bladed rotors, and therefore can produce more thrust, which is necessary for hover conditions, where the motors have to lift the entire vehicle without the help of the wings. The inner 2 rotors, however, are meant for forward flight. How do I know this? Well, the video seems to suggest that it's primarily the inner 2 rotors that are spinning. But not only that, they are 2-bladed rotors, which makes them more efficient. In case you don't know, the less blades that are on a rotor, the more efficient the rotor becomes. But that is with the trade-off that there is less thrust that can be produced from that rotor itself. Now, another interesting thing they did was they have the outer 4 motors mounted with an angle. This one I'm not too sure about, but I think it probably has something to do with increasing the yaw authority of the vehicle and hover. Basically, by putting a motor at an angle and spooling up that rotor, you get the torque from the rotor, but now you also get a component of thrust that causes a moment which supplements the motor torque, helping the vehicle yaw. But I'm a little confused about it still, because this would mean that the rotors mounted on the vehicle are actually mounted in the reverse way. So essentially they should be spinning the other way around in order to supplement the yaw authority. So anyway, that's sort of what I found really interesting about this vehicle, which is why I wanted to make my own much smaller version in order to see how it performed on that scale and sort of get a better idea for how it actually flies. So I'm currently designing this thing, and I'm essentially using the mini Cubit cab model that I had from a previous video. I also found some pictures of the Prime drone, and I'm kind of reverse engineering based on those pictures. So let me show you what I mean. Okay, so essentially I need a side view and a front view of this thing. So I took this from the video, and I took this picture from online, and I kind of just put them in here in the sketch, and I sort of just based everything off of those two pictures alone. I'm also not going to use 6 rotors. I'm instead just going to stick with 4 rotors because it'll be a lot easier to make. Especially at this scale. It was actually kind of an annoying thing to design because there's all sorts of angles going on here, and I essentially had to use mostly lofts in order to make it. I'm using these magnetic wing detachments like I had on the mini Cubit video, so it's the same sort of concept where this whole wing can easily come off with just magnetic detachments. And then the wing I'm going to make out of foam, and then I have these carbon rods which will go to the wing and it'll sort of hold everything together. Okay, let's throw this thing on the 3D printer and start making it. Ooh, smoky. Alrighty, so I just finished building this little guy. It's a weirdly shaped quadcopter. Let's see if it flies. Alrighty, let's see what happens. Totally works.
I wanna learn to appreciate the space.
This is fun.
I know, I know.
I think it's easy.
Someone cancels their delivery. Coming straight back.
It's not possible.
No, it's necessary.
Come on, Charles. Ease it up.
So some final thoughts. It's a ton of fun to fly. In fact, it's really easy to fly. If you can fly a standard quadcopter, you can fly this thing even easier than that, I think. With the wings, it really helps it fly in a straight line, and it helps you keep coordinated turns. And the thing just tracks straight as an arrow, so it's really fun to fly. In the future, I might add a current sensor and a GPS module so that we can measure the power and the airspeed, and then we could essentially figure out just how efficient this thing is with the wings and without the wings, which might be pretty interesting. So maybe I'll do that in a future video. Also, if you're interested in building your own version of this, I will drop the STL files down below so that you can 3D print this thing. And yeah, essentially you just need a normal Betaflight flight controller, whatever flight controller you have that'll fit. And there's really nothing special about it, which is super nice. So yeah, it's an easy build to do. And yeah, other than that, this was a ton of fun to make. I changed up the video style a little bit, so hopefully it was still semi-entertaining. Okay, that's it. Thanks for watching. Bye.
Well, I'm an idiot.
Damn it.
How did I do that? And I was like, it was impulse reaction, disarmed it. And forgot that I wasn't even flying yours.